In this video, we're going to talk about dilations that are not centered around the origin. So we have done dilations before, but all of those dilations were centered around the origin, where these problems, the dilations will not be centered around the origin. So the first things we're going to talk about are how to find the center and how to find the scale factor when your dilations are not centered around the origin. So to find the center, you're essentially going to create a system of equations. Using lines. So you're going to connect a set of points, for example, E to E prime or D to D prime, twice. So if you do E, you're going to go from E to E prime, and then you go from D to D prime. So E to E prime, D to D prime. Or a different set of letters, just make sure you're going from the same one to make a line. So where those two lines intersect is the center. So you'll have something like this, and then that's going to be your center of dilation. So that's how you find the center. To find the scale factor, you're going to count and see how far a point is away from the center. And then you're going to create a fraction or a ratio for that, where you have the distance for the prime point on top and the distance for the non-prime point on the bottom. So let's look at an example of doing these two things. So this is the first example. We're going to connect a set of points. If you have points that are on a horizontal or vertical line, I would connect those first because those are going to be the easiest. You don't have to worry about slope or anything. So D and D prime. I'm connecting D and D prime. They're on a horizontal line. The next one I'm going to connect is going to be F and F prime. So when I connect those, now you could use a ruler and make your line a little bit straighter. Those two lines meet at this point right here. So that is your center of dilation. So that point is at -2, +1. And now we want to see how far, we're going to find the scale factor by seeing how far our points are away from that center. So I'm going to use D prime and D because it's on a straight across line. It's going to be a little bit easier to count. So D prime is 2 units away. So that's my distance on top. Remember, you want to have prime on top. And then our D is 1, 2, 3, 4 away. So D prime was 2 away and D was 4 away. So we're looking at 2 over 4, which simplifies to 1/2. So our scale factor is 1/2. Or you could put 0.5. Let's look at the second example. So same idea, we're going to connect 2 sets of points to see where those meet to find our center of origin for the dilation. So the first set of points I'm going to connect are B and B prime because they're going across this horizontal line. Makes it a little bit easier to connect them. So that's one line. Next line I'm going to do between C and C prime. So remember, you could use a ruler to make sure that your lines are straight, or you could just make sure that you're counting the slope. So that's my line between C and C prime. So you can see that these two lines meet right there. So that is our center of origin for the dilation. The coordinates for that are -1, 0. Now I want to find the scale factor. I'm going to make my ratio using B prime over B. Remember, you want to make sure that you have prime on top. So we want to count the distance for B prime to the center. So B prime is 1, 2, 3 away from the center. And then B is 2 away. So our scale factor is 3 over 2, or 1.5. Okay, now we're going to flip to the back page. And we're going to figure out how to dilate a shape that is not centered around the origin. First, you're going to plot the center that's given to you. Then you're going to count the rise over the run. You want to make sure that you start from the center when you're counting the rise over the run. That's really important. And then you're going to multiply the rise and the run by the scale factor. Mark the new points starting from the center of dilation, not from the origin. So we're going to multiply each rise over run, and then you're going to count that new rise over the run from the center, not from the origin. So let's look at a couple examples. Alright, so this first one, this capital D stands for dilate. We're dilating triangle ABC. This is our center that we're dilating. So we need to make sure that we plot that center. So this is the center. And then this is our K value. So that's a scale factor. Alright, so first thing we want to do is plot the center. So the center is at -8, +9. So that is our center of dilation. So we're going to count the rise over the run for each point from the center of dilation. So I'm going to do B first. So, B, I am going to go down 2 and right 2. So my rise over run will be -2 over 2 because I went down and right. So I'm going to multiply both of those by the scale factor, which is 2. So you're multiplying the top and the bottom by 2. So that's going to make it -4 over 4. So from the center, we're going to count down 4 and then to the right 4. So down 1, 2, 3, 4, and then to the right 4. Right 1, 2, 3, and 4. So that would be our B prime. Now let's look at A. So to go from the center to A, we're going to go down and right. So we went down 1, 2, 3, 4, 5. So it's -5, and then we went to the right one, -5 over 1. So we're going to multiply both of those by 2, because that is our scale factor. So our new rise and run is going to be -10 over 2. So that's what we're going to do. From the center, we're going to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then to the right 2. 1, 2. So this is where A prime will be. All right, now let's look at C. So to get to C, We're going to go down and right. We went down 1, 2, 3, 4, 5, right 1, 2, 3, 4. So negative 5 over 4. Multiply them both by 2. I'm going to turn it into negative 10 over 8. So that's what we're going to count. Down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now to the right 8. 1, 2, 3, 4, 5, 6, 7, 8. So that is C prime. So now connect those. And that is our dilated shape based on a scale factor of 2 and a center of negative 8, 9. Let's look at another example. So here we're going to dilate triangle ABC, where this is your center. So 1, 4 is the center. And then it's a dilation of a half, so that's your scale factor, your K value. So first thing we want to do is plot the center. So our center is at 1, 4. So it's actually at the same point that B is, which means that B is not going to move. B will be in the same spot. So we only have to look at A and C. So let's figure out what the rise over the run is for A. Remember, you want to make sure that you start from the center that's given. So we want to make sure that we're starting from 1, 4 when we count the rise over the run. So let's go to A. We're going to go down 1, 2, 3, 4, 5, 6. And to the left 2. So negative 6 over negative 2 because I went down and left. And we're going to multiply each of those by a half or by 0.5. So multiply by 0.5, multiply by 0.5. So our rise over our run for A prime will be negative 3 over negative 1. So we're going to go down 3 and to the left 1. So from the center, 1, 4, we're going down 1, 2, 3, and to the left 1. So that is where our A prime will be. Alright, so let's do C now. So our slope, our rise over our run for C, looks like we're going to go down 1, 2, 3, 4, 5, 6, to the right 1. So negative 6 over 1. Multiply them both by a half, or 0.5. So C prime, our slope will look like negative 3 over 0.5. So you're going to go down 3 and to the right 0.5. So let's look at that on our graph. Down 1, 2, 3, and then to the right a half. So it's going to fall. Right about here will be our C prime point. So connect those, and that is your dilated triangle. So that green one, because remember, B did not move, so B prime is in that same spot. So that's dilated around 1, 4 by a scale factor of a half.